Good day to you. This is Galactic on the third day of August in 2025 on a Sunday. We are entering a new series to recapitulate the discoveries made over the past 3 years here at Galactic, beginning at the geometry that opens up physics to re-examination using rational methods, which is the preferred method of science. In this case, what we have found here at Galactic, beginning about 4 years ago, is that there is an original geometry which is still unknown to science. Although I know about it, no one else does. So that's a rather provocative entry point to a discussion of modern science. But it was not my intention originally to probe science. I had been interested in cosmology because it's a branch of astronomy, and I had become interested in quantum mechanics because as an astronomer I would certainly like to know about the nature of light. And it's the nature of light that is utterly baffling. Along with gravity, one could easily characterize the situation in science as a complete non-understanding of light and gravity. Gravity is monopolar, which makes no sense, and so gravity is completely not understood. Newton did find a mathematical way to quantify the effect of gravity, but as for the physics of gravity, it's completely unknown. We do know that it's based on the proton, but it is not acceptable information, and so it is ignored due to, I would just have to put it, sociological forces that have entered the regime of science and has compromised it so that it can no longer function normally with a feedback system. Now, from my point of view 4 years ago, what I was doing was studying spherical rotation. I became interested in the sphere and finally was able to discern that there is a geometry of the sphere, and that's what we'll talk about today. Now, because we are very limited creatures, we do have to take cognizance of our own limitations in examining the universe by any means. It is now known, it has been proved, that we are DNA programmed to see straight lines, and we are able to deal with straight line logic. That is the sole modus operandi. I believe it's modus operandi. I don't know why it's not modus operandus. But whatever the Latin may be, the way science works is strictly with linear logic, linear geometry, linear mathematics, and linear numbers. What I was able to discover using the prior research of such notables as John Horton Conway, I was able to discern that there is a marked misunderstanding in our mathematical system concerning the so-called 4 basic operators. Because we're in a synthetic sequence and I have to be brief in order to cover a lot of ground at once, I will simply tell you, and you should accept, that there are only 2 operators. Add, which has an additive inverse called subtract, but it's really just one operator, add. And we use that for the object called the line. And it has now been proved, although it is not publicized anywhere or taught, that the line and add have an identity relationship. I've gone into that in such detail that it's probably overkill, so I pray that you will simply accept what I say for now, although you're perfectly free to go back and review my prior 1,070 videos where I perennially, repeatedly cover the mathematical basis currently in use in science, which is known to have severe flaws, but not yet known to have severe flaws in the area of operator usage. Because there are only two operators, which can be called add and multiply, it makes the approach simple, but at this fundamental level, I would have to say at the outset, confessedly, this is going to be very difficult for you to swallow until you think about it and work this out in your own head. That is called science. So you are being introduced to science, which I'm sure you're already as familiar with as you think you need to be, but nobody can say that. We're always learning. So to begin with, I would like to introduce this video series, beginning really yesterday, as the summation of my work in as short a period of time as possible. At this phase, I will not be using diagrams, although I believe that it is important to eventually include diagrams so that this can be presented in a more comprehensive manner. But for now, we're simply going to explain the sequence of discoveries made here at Anagalactic, leading to the massive series of discoveries in physics that unlocks physics and solves all the problems in physics. We do need to go back to the mistakes that were made that produced the rather tragic situation now in science, which is fully halted. And there's no feedback mechanism, so there's no way out of the trap. There's no way out of the labyrinth, which is now psychotic. So we have a false cosmology. We have several really false models that are dominant and cannot be dethroned and never will be dethroned. You might say that therefore I am on a fool's errand. Be that as it may, I am right, and I will be correcting science fully. So beginning now at the fundamental errors, which so far have not been discovered in consensual science, I've discovered them. And it goes right back to what is a number, what is the line, and what have we missed. It's very difficult, I would say, for a general audience. This would just be not you personally. I'm never pointing the finger at any person. I assume that you do trust me. But if you don't, you only have two choices. You had better trust me, or you had better get your ass out of here. Because I will not stop. I will not be contradicted. This sounds like bad posturing. I have no choice. This is the demand of science. Several scientists have risked their lives or reputations in order to further truth, which is what science is for. It is to promote truth. This is meant, according to the structure of science, to leave out religion, to leave out the supernatural, to leave out philosophy, to leave out anything that cannot be proved with binary logic using the scientific method. However, as I've pointed out several times over the past 3 years, it is impossible, absolutely impossible, to divorce science from the human equation. We will get around to that. From time to time, I do interject a video or video series devoted to revealed religion, which I'm sure you don't like. That's too bad. But you don't have to pay attention to that, because I do make a clear division between strict science, which has a very restrictive and restricting methodology, which has nothing to do with anything that cannot be proved with rigorous logic. And I make the distinction between that and what is most important to humans and what science is actually all about, which you simply cannot accept according to your current level of brainwashing, which is what it is. So all of that should be obvious to you. If it's not, you've got to start towing the line and listening to me, or you're perfectly free to go in peace. I have nothing against anybody. I'm not trying to pull down any pillars. I have no connections with the industry. I stand nothing to gain. I'm under strict orders of heaven, and if you don't like that, you don't need to, because it won't appear in this video. But I believe every scientist today is required by moral law to declare his religious position. If you're an atheist, you're out. There's no such thing as atheism, and anyone who says that they're an atheist is a self-confessed liar and a full deceiver. And the main target of deceit is oneself. If you don't have any idea of the supernatural or the origins of this ecology or humanity or yourself, you're a free man, you're allowed to be a jackass. But not here. I won't allow it. But you don't need to worry, because I won't confront you personally. I don't support any religion except, of course, the only one that's ever been, which is Islam. So now you know where I stand. All right, so today we're going to go into the mathematics, which is absolutely required in this situation, because all the problems in physics are mathematical errors. This goes right back to the fundamentals, so far back that it's irretrievable. This cannot be accepted. I'm merely broadcasting the truth because, as I said, I have to. That's exactly what science is meant for. You may not credit that, that's okay. But I do hope you listen, because I will not lie to you, and I can prove everything I say on the mathematical and geometric side, leading to my several dozen major discoveries, which completely solves the quantum paradox and everything in so-called cosmology. Most importantly, from the point of view of an astronomer, which I am, and I hope you are too, at least just look at the night sky from time to time. That's astronomy. You don't need a telescope, although it certainly helps. If you want to do galactic astronomy, which I believe is the cutting edge, you will need a telescope. But if you want to actually see the galaxies beyond Andromeda and one or two others which just look fuzzy in the most powerful telescope you can purchase, you still will not see a galaxy, because there's not enough light. And this is simply a physical principle, that even Andromeda cannot be seen, not even with a telescope. You can find it and you can see a patch of light, but you cannot see the spiral arms. You will not see the beauty until you purchase photographic equipment, which will cost you as a buy-in $50,000 minimum. $100,000 is probably optimal, but $500,000 would not be out of the question, and many people have made this investment. I have no idea how they manage to do that, but they're motivated to do so, and I fully agree with that. All right, so that is our bracketing information to get into the mathematical side of my geometric discovery. From the last video, if you did watch it, although don't worry, I recommend that you watch it, but I always keep these videos self-contained. What we talked about was the other geometry, the one that I discovered. It is called an intrinsic geometry. This is fully unknown to science at any level in any department. But it is a verified fact now that I discovered the original geometry, which Euclid simply could not have figured out. That's a bit difficult to say absolutely, because anybody might be able to figure this out at any time. Nobody ever did. I'm the first man to ever discover the actual geometry that governs the universe. Obviously, it has to do with curvature, we all know that. But nobody has realized that there is an actual geometry that fully incorporates the linear geometry we already know about. My purpose today is to show you conclusively, so you can prove it to yourself. That is science, that's the scientific method, is to produce the proof, so that the discoveries that I've made can be communicated to your mind, so that you can absolutely verify what I say and then forget about me, because you won't need me after that. That's called science. There are no personal opinions in science. So, to introduce my original discovery that got me on track of the greatest discovery sequence in the history of science, I now introduce you to the numbers that exist in space. We are spatial creatures. We cannot understand time. Although I will show you that I do understand time because I can prove what it is exactly. Nobody has ever done that. Einstein actually missed the mark. That's fairly well known, but it doesn't matter because there's no feedback system for men such as Dr. Alexander Unziker, operating out of Deutschland. A truly tragic story. I admire this man. He's trying so hard. He sees the flaws, but he doesn't know the right geometry. And everybody compared with me now is in kindergarten. I am a PhD in this area. And that's not being overbearing. Remember, I stand to gain nothing. I will not get fame. I will refuse it. I also certainly will not get money. I hate money. So that's a little bit more about your professor here. Let's get into the mathematics without the benefit of any diagrams at this time. As part of this series, I have reviewed again the history of the viewership and response from whoever has listened to me. There have been several thousand people who have tuned into my station, but not for very long, and this is typical on YouTube for an outlier channel such as mine. I do not present sensationalism, although what I present is far more sensational than anything you'll find anywhere else. That's simply plugging my own channel because no one has noticed it, and I really doubt that anyone ever will, but you've noticed it, and that's all I care about, is that someone else knows this. That's called science. So the number system that we use is a one-component number system. That begs the question, is there some other kind of number system? Yes, we're well acquainted with it. They're called fractions. And fractions are not one-component numbers. You can see that for yourself by simply writing a fraction. The simplest of which is 1 over 1. That is a two-component number relating two quantities together. We call that division. That is a distinct error. There is no such thing as division in the universe. There certainly is no such linear operator as division. As I pointed out in the prior lecture, which was devoted to the geometric side, but necessarily incorporating mathematics, really arithmetic, the line is identified with its operator, which is just one operator for distance called add. So to summarize that, the line has an Archimedean balance point, and that's a Euclidean point which is used in science and has led to the supermassive black hole singularity, which is a mathematical error. Also, the so-called Big Bang, besides being complete nonsense and anti-scientific, is simply based on a mathematical error, also based on a misinterpretation of redshift. I've devoted several videos to that. If you do get to my station and look up the word redshift, you'll have hours and hours of discussion on the error that was made to produce the insane Big Bang theory. But essentially, from our point of view today, it is a singularity. That is the current definition of the Big Bang. It is a mathematical singularity. What is a singularity? It is Euclidean zero, which Euclid did not call zero because he was not dealing with numbers at all, although he knew the connection between numbers and geometry at the linear level. So we're talking about either a straight line or a curved line, and those are the only two kinds of line. The straight line can have different orientations on the plane, but basically it's any direction you can point a ray. Now a ray is not a line. What Euclid talked about was a line which is bipolar, as anyone could see by drawing one. If you draw a line, you have to start somewhere. You could call that the origin, but if you draw the line first in one direction and then in the opposite direction, you have basically invented the negative numbers, which do not exist. Negative numbers are not true numbers. That may sound preposterous. I will simply tell you what I know, and you can decide. That is called science. I'm communicating the truth. Whether you accept it or not is completely based on your free will, but it's really based on your level of intelligence. And if you don't understand what I am about to say, or that I have said so far, it is because you're unintelligent. That's a fact. That's simply, and that's my subjective point of view, you might say. No, it's not. It's an objective point of view. And I'm forced to tell you, if you want to be intelligent, but you can't understand what I'm saying, then you need to listen. It's because now you're going to know the truth about mathematics, numbers, and the relationship between numbers and geometry. There are only two geometries, but science has only used one geometry. Probably should have chosen this finger. But this finger is reserved for the universe's idea of what is a number, what is mathematics, and what is geometry. Physics has no idea. Only I know, because there are two geometries. One of them is called derivative geometry. That's Euclidean, because a straight line does not actually exist in the universe. There is no such thing as a straight line anywhere in the universe, because everything is curved. Nothing is straight. There's a footnote, though, which I won't go into now, but I have in the past. Because actually, I myself have proved that there is such a thing as derivative geometry, which is all that science uses. We only use systematic linear space, currently called 3D, for the derivative extrinsic geometry of volume space is called 3D. That's a distinct error. And then Einstein made it worse by adding an imaginary, orthogonal, fourth dimension, as we call it now. And that is the dimensionality of space-time, which is ridiculously wrong. It does enable space travel, though, which has a most morbid association, because it's not humans who are in outer space. But I will not go down that path. I merely am suggesting to you that the reason for going into outer space is unknown to you. But it is known to something. It's not a person, but it is a controlling agency that definitely needs to get into outer space for reasons which are strictly anti-human. So that's your space program. And that's why Einsteinian mathematics, which is hypercalculus to get hypercurvature in space-time, is so critically important to the extent that it's fully worshipped by the atheist cartel now known as physicists, who are funded exclusively by the United States government, if that tells you anything. So that's why space-time is so important. It's because it enables the United States, whatever that is, to get into outer space for whatever reason it has to do so. I'm sure if you're a full-grown adult with a fully operative mind, at least in this context, you can put the pieces together. But I don't go down that path. I don't like to mix religion, if that's what that is, or philosophy if you prefer, with strict science, which is only after the truth in the most rigorously provable sense. So we return now to the basis of what has become Einsteinian mathematics. Alright, so you're fully aware that space-time is now worshipped, although I won't use that word any further because it might cause your mind to go off its rails. I don't wish to confuse you. I am instinctively prompted to just say the truth the way it is. But that can be quite unfair and counterproductive. So I'm being suggestive because I'm running out of time. So that's my apology to you for bringing in issues that I'm sure make you want to vomit. And you're fully free to hate me, but you'll never touch me. You can turn this off, and that's the end of our relationship. All right, so let's begin. If you do draw a line, it's a ray. There is no such thing as the other side of the line. When you draw a line, you must have an origin. The place where you put the pencil down on the paper is a Euclidean point, and it doesn't exist. That's the definition of the Euclidean point. It's null in the mathematic sense, the numeric sense, the physical sense, the geometric sense. It's not there. So why would Euclid have begun with such a ridiculous axiomatization? It's so he could draw a line. And it can be proved that if you do start to draw a line, whereby you must start by making a point, that can be proved to be numeric zero, which is the numeric equivalent of non-existence. A moment's thought will convince you I'm not exaggerating. Zero simply does not exist in any way, and neither does the point, although retroactively you can prove geometrically that both exist. So there is such a thing as a zero, and there is such a thing as a point, but only with reference to the line. Because the only reason to make a point is to draw a line. And when you do, it only goes in the positive direction. Only positive numbers are numbers. There are no numbers less than zero, because zero itself is not a number. And I shouldn't say because. Both of those statements can be proved. There is no such thing as negative numbers, and there's no such thing as zero, but by two different proofs, which I'll get around to because that is the purpose of this brief lecture. And this is a lecture because there's nothing over here except that blank piece of paper to make this into a presentation, which would include video graphics as well as just my audio voice. But for now, for reasons I've tried to outline, I'm introducing this topic strictly as a lecture, so that you will know, finally, what you weren't taught in school and you'll not be able to find out any other way. Because everything I'm about to say from this point forward is my discovery. I will not get a Nobel Prize. I'll be lucky if you even watch this to the end of the video, and count on it, no one else will. So, whomever I am speaking to, and so far you don't exist, you're just a point, in my mind doesn't exist, but that doesn't mean that the point may not have relevance. So, whomever you are in the future that actually listens to this, thank you. Because that fulfills my mission. It's just for one person. I would prefer that it was tens of millions of people. That would be appropriate, but that is out of the question at this time, except for a very tiny, anomalous miracle. Because it's too late to correct science. It won't be corrected. It has its own defense measures. So, space-time is here to stay, and I would have to say, even I would agree with that, because it is a valid derivative solution. And I want you to get used to the concept of a derivative. You do know, at least abstractly, what is the calculus. The calculus was originally invented to derive one kind of number from another kind of number. That is not how you were taught, but that's a reasonable way of putting it. And that's the calculus. Although one would need to go into the details, then, of what specifically is the calculus. I'm merely describing it abstractly. It is the relationship between a certain kind of number, called an integral, and another kind of number called an infinitesimal. And according to the fundamental law of calculus, as it is taught, those two are invertible. That the infinitesimal is related to the integral on an inversion. So once you obtain an integral, you can reverse the process and reobtain what you got the integral from. But you can also get an infinitesimal by reversing the calculation. This has to do with a curve. Calculus is only used for curves. So it's a major tool. It's a tremendous discovery. But it's a principle, not really an operation. If it were to be called an operation, then technically it's a transdimensional operator. Because when you take, for instance, the infinitesimal, I will not deal with the integral because it's not necessary. You simply describe either the integral or the infinitesimal, and you can figure out the other. Really, Leibniz concentrated, one might say, on one side, whereas Newton worked on the other side. But you do need both. The calculus is two operations, depending on your needs. If you need to compute an area under a curve, which is how the calculus was discovered, really for the elliptical orbits of planets in the case of Newton, he was attempting to get a better solution for celestial mechanics than Kepler was able to obtain. And he was successful, but he used quite a nasty trick. And he disregarded it because he was only after approximations. And so it stands to this day. So the calculus is not a geometric operation, although you could say so by extension if you're willing to redefine the definition of a number. I am not willing to so allow that because it's forbidden. I've proved that. So the calculus is not a very wise thing to attempt, but it's very good for space travel. It's also good for building freeways, and in fact the calculus is indispensable for anything you care to name in the Industrial Revolution, which led to our new modern way of life, at least in the favored white countries of America and Europe, and now it's gone worldwide. The advantages of calculus are all around us, which seems to justify the Euclidean number system, although that's extending Euclidean geometry into the future to the present day. The number system for the line was very slowly, agonizingly discovered, and zero was not added to the system until centuries after Euclid. The negative numbers actually were introduced first because there is a certain logic to a negative quantity, but only for money or grain, really for a debt. Because if you're transacting monetary sums, you may have a negative balance. That does make sense because it's strictly linear. If you have an amount of $2 that you owe someone, on their side of the fence, they might write down in their ledger a big red -2. That it's not, they don't have the $2, they have -$2, which is why they'll send out thugs to break your fucking legs until you pay that goddamned money. So you see, I have a very serious emotional issue with that form of logic. I hate money. So, a little bit more about me, so you know why I present my information the way I do. Is to drill it into your head that what I'm saying makes sense. But only the proof matters. That's what we're getting to, but I'm warming you up for it. So, off the bat, I'm saying from your point of view this is hypothetical, but from my point of view it's absolutely proved. There is, in fact, no such thing as negative numbers. They don't exist. There's no such thing in the universe. The universe does not recognize negative quantities. They just don't exist. In the number system, everything is positive in the universe, and there is also no zero, for the simple reason that that's nullity. Now, the reason we use zero is in order to have an origin for a ray. So that goes positive. That's called distance, and I covered that in the prior video. So now we're up to date, and we can go forward with the mathematical basis of a brand new geometry that physics will never accept because it's true. Physics does not want the truth. That's a fact. So, even though there's no hope of this being accepted, I am forced to state the truth because it's the truth. You consider that to be crank? That's perfectly fine. Get lost. You're no sweat off my back, but you'll never argue with me or contradict me, talk back to me. You certainly won't touch me in any way. You can leave a nasty comment. Actually, only one person that in my 3 years has even bothered to leave a comment. Every now and then I get a dislike, but the person is a coward. They don't leave a comment. If you leave a dislike at someone's channel and you don't leave a comment explaining your disliking, you're a coward. You're certainly not a scientist, because no scientist can afford to be a coward. So I hope you're brave, you're courageous, you're willing to learn from the universe. It's simply through me. I'm telling you what the universe says. Sound megalomaniac? Every discoverer has to go through this. No, I'm not megalomaniac, or I'd be out to get your fucking wallet. So, that's why we have zero. It's because in retrospect, in the 2,500 years since Euclid, we've learned that that point that he invented in his first sentence in Elements is a non-dimensional object. It's not really there. So how can we say it exists at all if it doesn't exist? It has a relative existence in a space in which it exists. So it does exist, but only relative to what you're doing in the space. So that's a lot of gobbledygook. I hope I'm not confusing you. But don't forget, nobody has ever seen this except me. So let's go ahead with our proof. You can say that there's a point, which is nothingness, it's null. But it has a retroactive meaning once you start computing distance, which is exactly what Euclid wanted. That's why he's virtually worshipped. Meaning that in a scientific sense, not, oh, let me bring you candles and of course my wallet. Euclid was simply axiomatizing linear space. That's what he did. A magnificent discovery because it gives us the number system, which is entirely positive counting numbers. Correctly defined, a number is always a whole number. And we'll proceed from there because there will be a footnote to everything. But the statements I will make henceforth are absolutely true. So, the only numbers there are begin at 1, because that's the metric of linear separation, called distance. Distance has a definition of 3 words, all of which are critical. So learn first the definition of distance. It is linear, spatial, separation. So the jump to 1 has to be what? It has to be 0. Otherwise you have no 1. Because 1 here is not a counting number. It's not an apple, or 2 apples, or 3 apples, or 4 oranges. It's not an object that you're counting. It's not a coin. It's not an apple. That's the proper use of counting numbers, is to count things. But the counting numbers have a second use, whereby they are no longer strictly speaking, physically counting things. Instead, you're abstractly counting metrical units of space. This is a spatial separation between 0 and 1. Now you can see that with your own eyes, even if you're blind. And blind people can do geometry, I would suggest, possibly better than people who use their eyes, because you can see in a much more direct fashion, just using your mind, what is distance. You don't need to be able to see it. You actually cannot see it, because it's through space. Now, a distance can be measured along a surface such as wood or steel or what have you, and then it's called a length. But it's the same principle. You have to start from somewhere. Well, if you're going to use a metric, which is simply 1, 2, 3, 4, then you have to have a starting point. And that is the correct use of point. It's the starting point. Now, is anything else on the line a point? Euclid said yes. That when you have your metric based on an index, these terms I hope you understand, but let me refresh your memory. The metric is what you're doing. In this case, it's linear separation, linear spatial separation. So that's the metric. But then you need an index for the metric. What are your units? Well, then you have to use the counting number system because you're measuring things. It's just they're abstract things. They're equal units of distance on a line. That's the metric of distance. The index of distance, by definition, is 1 because there's no lower number. Remember, according to my hypothetical approach, which I've proved, but you're unaware of that, if you are aware of it, this is just review. But in order to have 1 as a distance, to have your index of your metric, you must have a starting point. So Euclid said that the shortest distance between 2 points is a straight line. And you were taught that in school. That requires no proof. I'm merely restating the proof in extremely precise language because of what we're going to do next, in order to get to curvature. That's the goal. We have no metric for curvature. We use the calculus, and in another context we use the complex algebra. And those are the two main tools that have opened up curvature to our analytical methods, which are so hideously flawed that it's beyond recall now. Science will never recover. Science has ended. Not here, though. It's just industrial science or consensual science. It's now dominated by a group mind system that will defend itself against the truth. But you can open up your own mind to the truth. I'm opening up your mind to the truth that the universe says, not your universities or your professors. This is what the universe teaches us. When you have an index for your linear metric, you must have a 0. And that's the value of 0. It forms the origin of the metric of distance. You must have a starting point. All right, without going into the hideous details of is the line made of points, Euclid said it is. And that's called quantization. And that may be the first time you ever heard the word quantum used the correct way. The jump from 0 to 1 is a quantum jump because there's no smaller number. Now, when we use distance, we simply make up a distance. It's purely arbitrary. It could be an inch, in which case you measure the distance to a star in inches. That turns out to be a little too small to be useful. So instead, the French suggested a meter, which is based on a meridian of longitude. It's a fraction of that, and that was computed, and now it's made an arbitrary unit. It's the arbitrary index for spatial separation, is the meter. And you can look that up. That's permanent. Whether it's right or wrong is immaterial. You have to make up some unit. Now these days, now that we've gone to the subatomic level and we're analyzing the fundamental particles, such as the proton and electron, and you could say even the photon, the three fundamental particles are those three things. With the photon, of course, having a huge footnote, and the electron having another footnote, and the proton another footnote, but not as long, or not as complicated or complex. And at that scale, you get down to the limit of what you're able to measure. And you may have heard of the Heisenberg uncertainty principle. We won't go into that detail right now, but that's quite a profound principle. That there is a smallest measurable spatial separation called the Planck length. And the Planck length is currently estimated to be at about 10 to the negative 34th power of what? You can look that up, but it is simply a distance. But this distance is not as arbitrary because you're getting down to the smallest possible distance measurable, below which you can no longer tell. You can't measure unless you can distinguish between something greater and something lesser. In this case, something lesser. There's a limit to that. You can't measure the distance from 0 to 0. That's nothing. So there does have to be a jump somewhere. That's called the quantum jump in linear space, and that is correct. You may have never heard the word quantum used that way. Quantum is an abstract word. It's an adjective. It's not a noun, although it could be used as a noun, and I'll show you how it can be used as a noun. For instance, in the term, currently at the cutting edge of science, the quantum of gravity, which has never been discovered. That's what science is looking for right now. So am I, except I discovered it. So we'll get there to the quantum of gravity. But in order to even understand what that would mean, you have to know what quantum means. It means the smallest unit of anything. In this case, the smallest measurable unit of gravity. That in itself will never be discovered the way it's being sought, due to the limitations of linear mathematics, which is the whole purpose of this video presentation, is to show you both the problem and the solution. But in order to see the solution to any problem, the very first thing you must do, this is according to the polya method. That's a man who is working out of Stanford, whose book on how to solve problems has gone to at least 34 editions, which is a lot. So Polya is internationally renowned for his problem-solving approach, which begins with this statement, which must come first. You must understand the problem. In other words, you have to fully understand what is the question, or you have no possibility of finding a solution. You cannot find a solution to a problem that you don't understand. I'll leave that for you to mull over as homework. I recommend Polya's book, How to Solve a Problem, which I'm not sure is the exact title, but if you look up Polya, you'll be able to find that as an open source book. So the problem, in the case of linear spatial separation, what we call distance, what Euclid would call distance, is to find the smallest unit that's measurable, so that you know that you can't find anything smaller. Well, we believe that we have got that down to a very relatively accurate spatial separation. And now you have to understand the paradox that's involved in any quantum jump. Because what is a quantum jump? In this case, it's the smallest space that you can measure on a line. That's called the Planck length, about 10 to the negative 34th power in the units that are employed. So it's extremely tiny. You would have to know 10 to the negative 34th power of what? Look it up. It's very good homework. But you know what I'm saying. It's the tiniest possible measurement, going to the Heisenberg uncertainty principle, which defines that length as half of a wavelength. Although that would need to be explained. Which wavelength? There's all kinds of wavelengths. Well, it's the smallest half of the smallest wavelength. That's quite a conundrum. But it is relatively, it is the only way to make a metric. You do have to have a smallest index, and that has a discrete value in cutting-edge physics. It's accurate enough, I would put it. But it's very difficult to measure, because how do you know if someday you might not measure something half as big, in which case it would be half a Planck unit? Well, there is no such thing. And that is the quantum paradox. That there's no such thing as a metric without this quantum jump. Which really blows the minds of most people who try to think through this deeply. You do reach an absolute paradox that cannot be solved. I solved it. It's really quite a magic trick to solve that problem of the quantum jump, because there's no space between 0 and 1. Well, if there's no space between 0 and 1, what is between 0 and 1 if it's not space? We can prove that it is space. But to say that there's nothing smaller than that length of space is absolutely contradictory to human logic, to mathematical logic, although I'll show you the way out of that. It has to do with curvature. Because if you have a smallest distance, and there is no smaller linear distance, what if that distance were curved? You would then be able to prove that there is another metric on that curve that perhaps is not linear. But that doesn't make sense to us, because the curve would be of greater length than the linear jump. So that doesn't make sense either, although it's a very interesting avenue of thought. We're challenging our own rational logical system. I discovered the actual logic system that the universe uses, which is based fully on curvature. And when the matter of the quantum jump is approached that way, you have a brand new framework of reference called a reference frame. In this case, that's an abstraction. But it is a reference frame for analyzing the quantum jump. Is it indeed linear? Or are we fooling ourselves in thinking that that's a rational proposition? Well, if you say that it is a rational proposition, that there is a quantum jump from 0 to 1, the smallest measurable unit, then you have science. You have physics, which is why physics has halted, because that's incorrect. You're not seeing everything. You haven't integrated what you're seeing into a higher system. So that's what we're going to explore now mathematically, as I attempted to introduce it yesterday in the prior video, geometrically. All right. So we have this quantum jump from 0 to 1 with no measurable units from 0 to 1, so it really is a jump. That's called the quantization of the line, because in order to use this as a metric, you simply repeat that distance until you get to the edge of the universe, which is being attempted, as crazy as that may sound, it does make rational sense to try to measure the linear distance from our origin, which necessarily is on Earth, or at least in a space telescope, somewhere in the solar system. You measure by Planck units to the edge of space, which is another paradox, because there's no known edge of space yet. And the James Webb Telescope has proved that. The major purpose behind the James Webb Telescope launch and deployment, which was a lot of money, and it's still out there doing its job, but the cat's out of the bag now. The James Webb Telescope is unable to discover what the current cosmological model predicts. There must be an edge. There is none. That is now known. And the whole model was known to be flawed, but nobody had a better model. So it's not going away until there's a better model. We'll get there eventually, but at this early phase, the first thing you need to understand is the metric of the line based on the quantum jump, which metricizes the line by quantifying it. It's quantized on points. So each segment, even though there is no measurable space between the index jumps, which are all equal. There's a Planck jump from 0 to 1. There's an equal Planck jump from 1 to 2. You're measuring in Planck jumps. And those are the points on the line. And they have to be whole numbers, or you have no metric. So Cantor's work was shit. Not completely, because he was dealing in an area of mathematics that was sorely needed, and Cantor is hailed to this day, along with Dedekind and Hilbert and some others, who tried to de-quantify the line so it would be continuous. I just proved to you that that's impossible. So Cantor's work is shit. I'm sorry, but it is. Because you can't de-quantize the line, or you have no metric. You have no distance. In this case, we're using the smallest computable quantum jump, which is the Planck length, which is half of a wavelength. Just so you know, that is the Planck length. It's half of a wavelength, however you go about defining wavelength, but it has been done. So I do accept that. I accept that the Planck length is exactly what it is stated to be. It is the metric of the line, which begins at 1 Planck unit and goes to as many Planck units as you need for any distance, because it goes to infinity. All right, so that's the linear quantum jump, the linear metric, the linear index. And now you know everything there is to know about the line. It's made of whole positive numbers, and 0 is imaginary. It has to be, because it's not really there. It is there geometrically, though, in terms of the geometry of the line. To the degree that 1 exists as a point, so does 0, because they're reciprocal on add. If you go from 0 to 1, you've gone a positive distance of 1. If you're willing to turn your mind upside down and inside out, you can then say that you can go backwards from 1 to 0, and you can assign that a symbolic value of polaric 1, which we say is negative because it's 180 degrees. We call that the opposite linear direction. So that is an extrapolation on distance. But in the universe, there is no such thing as negative distance, just as there's no such thing as negative 2 apples. There can only be positive counters. Counters do not count in negative space. They count in reality. That's called reality. And that's your introduction to reality, which at the end of this series, I will show you is a most important insight, that reality is only positive mathematically. There is no such thing as negative space. You can extrapolate that using mathematical methods, and sometimes that can be helpful. But in reality, in physics, there's no such thing as a negative quantity, and there's no such thing as negative distance, and therefore, there's no such thing as negative numbers. So there are only positive numbers, and the lowest one, by definition, is 1. And if you make that into a Planck scale metric, which is exactly what we want, then you're counting in Planck units of linear spatial separation, which is half of a wavelength. Already a tremendous paradox and contradiction. But that is the state of science, mathematically. You now know the truth about linear space. They're positive counting numbers in Planck units of distance. So that's the line. Positive Planck units of distance, beginning at 1 and then repeating 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and then you go on. That's linear space. The metric, the number system. And these are one-component numbers. I won't go into a digression on the possibility of there being a two-component number, but that is what I began by saying, that a fraction, for instance, 1 over 2, is a fraction. You can invert that, and now you have 2 over 1. So you see that division is an idiotic concept. Division does not exist in nature. There's no such thing as division. Because how would you divide anything that's real? You can't. Nature cannot be divided. I'm stating that axiomatically to challenge your mind. You may not accept what I just said. Oh, of course there's division. You take one apple and you chop it in half. And now you have 1/2 of an apple over here, and you have 1/2 of an apple over here. Yeah, that's correct. So division is a useful concept in certain situations, but it does not really describe what you're doing with those two numbers. When you have the little line with a number on top called the numerator and the number on the bottom, I want to just give you a quiz, which is simply to prompt your mind. What is the relationship between those two numbers? There is only one correct answer. They're proportional. The 2, because it's in relation to 1, what does that mean? We say that 1 goes into 2 twice, so that's really what it means. It's the inverse of multiplication, correct? You could say that, but it's geometrically incorrect. So what is the true nature of this so-called division operation? I say that it is not division because that's the incorrect definition of the relationship between the two numbers. The 1 is not there to divide the 2. If you invert that, you'll see this more clearly. When you have a 2, but it's on the bottom, what is the role of that 2? It's in relation to 1. What is the relation of 2 to 1 in the number we call 1/2? Can you answer that? You should be able to answer that. I'm trying to answer it myself right now. This really challenges our mind, I think, because we were so miserably mistaught what division actually is. It's proportionality. It's the relation of one quantity to another. So when you say 1 over 2, we think of that as being a discrete value 1/2. That's a mistake. It's not a discrete value. because a discrete value is a one-component number. We say it's reducible. That's really tragically wrong. No, it's not reducible, or we wouldn't have the number 1 over 2. That is irreducible. In linear logic, we say that it is irreducible, and that's how we were brainwashed. And it's brainwashing to say that. It's not division. Unless you force it and leave out the absolute truth. In other words, you're missing something when you simply say that it's division. No, it's not division. It's proportionality. And here's how you can learn that. It's by using what we call division the way we were taught, and multiplication the way we were taught, so you'll see the actual relationship between the two numbers in a fraction. And here's how you do it. You already have division, so we're going to say 1 over 2 is that number. It's a two-component number the way it's written. For you to say that that represents a one-component linear number is an extrapolation, which you may or may not be able to prove, depending on what you're trying to prove. So we're not going to say that that's a legitimate thing to do. We're going to say that the reason you're writing 1 over 2 is because that's exactly what you mean to write. It's 1 in relation to 2. Now invert it. Just invert the numbers and write that number right next to it. So you have 1 over 2 and then a space, and then write 2 over 1. So now you have two-component numbers. Well, that's simple. I hope I'm not confusing you, because if I am, you're not ready for this. Because this is first grade stuff. I'm not trying to talk down to you, but what's going to come next must be a shock to you, or you're not listening. So get ready for maybe what I hope will be the shock of your fucking life. What is the relationship between 2 over 1 and 1 over 2? Well, let me ask you this. What is the relationship between 1 and negative 1 if you're using the bipolar line? They add to 0. So 1 going in the positive direction in relation to 1 going in the negative direction, which we call negative 1, have a relationship. They're the same distance from the origin, aren't they? Yes, they are. This is 1 unit away, but in the opposite direction. What happens if you use the linear operator, add? You can add the two equivalent numbers to 0. So that's called the additive identity. And now I'm going to shock the shit out of you. I hope. Now look at the two numbers we have here. 1/2, which is smaller than 1. And 2 over 1, which is greater than 1. What's the operator that we need to use to correlate them? The same way that we correlated using add for 1 and negative 1. What's the correlator that's equivalent to add, but for these two numbers? Well, I hope you guessed. It's multiplication. And what happens when you multiply these two numbers together? So instead of 1 plus negative 1, you have 2 over 1 times 1 over 2. What does that compute to? I hope you know, or you didn't graduate from grade school. It's 1. The multiplicative identity is 1, not 0. So these two numbers, one of which is the inverse of the other, 2 proportion 1, is not commutative with 1 proportion 2 on the operator. Right? Or are they? What is commutativity? I should say that the number as it's composed, 2 over 1, is not the same as 1 over 2. For the same reason that negative 1 is not the same as positive 1. So we can also say that 1 over 2 is not the same as 2 over 1. But in the case of 1 and negative 1 adding to 0, the positive 1 is on one side of 0 at the same distance as the other version of 1. And so you use add to add them back to their origin. In this case, the identity is 1. And so one of these two numbers is greater than 1. And it's reciprocal, that is, when you invert the denominator and numerator, any number that you invert, if they're whole counting numbers, will be the reciprocal. And if you multiply the two reciprocal numbers, they multiply to 1. All of the numbers do that, if you define it correctly. That's called the binary number system. In a restricted, you have to be very careful how you define that. We haven't gotten there yet, but I'm trying to indicate to you where this leads. We're not using add anymore. When you have a two-component number composed of whole numbers, if one of the numbers is 1, that's what makes this so critical. One of the numbers in this number system must be 1, so that the two numbers that you make that are reciprocal, one of the numbers has 1 in the denominator, which is on the bottom, and the other one has 1 in the numerator. Well, that means that one of the numbers is greater than 1 and the other number is less than 1. Instead of being greater than or less than 0 on the line, you have two numbers, one of which is greater than 1 and the other which is less than 1. And when you compose this number system this way, you get the binary number system almost. What you get are the rational numbers. These are rational numbers, which means a number that can be represented on a computer. They're the computable numbers. And those numbers that we use on the computer are sometimes called binary numbers. They are also called the dyadic fractions. But strictly speaking, if you want to be precise, they're powers of 2. Powers of 2. You might ask, what is 2 to the 0th power? We'll come back to that in a future video. We're a little bit over an hour. I don't like to go this long, but this is necessary to maintain continuity on the most important lesson in arithmetic and mathematics and algebra and geometry and physics that you will ever hear. You basically just heard it, but I'm going to go on a little bit longer so that you get some sort of payoff and I don't just leave you dangling with this abstract notion of multiplicative space. That's just what we just invented. We're not using add or subtract because we're not using the line. The line has a center that's 0. If you're using simple distance, there are no negative numbers. You're using a ray, which is actually the correct definition of a line. The bipolar line is illusory because the negative portion of the line is imaginary. The positive portion of the line is not imaginary, in the sense that we can now measure distance on a straight line, which is exactly what Euclid was trying to prove in his opening axiomatic sequence. He began with a point because he had to, for reasons that you now know, because you need to have an origin for the line. That's a point. Then you need a second point on the line, and now you have the shortest distance between 2 points on the line. What we're doing is examining the fractional number system, which we have now redefined, that is, made a subset of the two-component number system we call fractions. If you insist that one of the numbers has to be unity, a most significant term which is synonymous with 1 in this context, you're using the linear index as one of the components of a fraction. If it's on the bottom, we say that 2 over 1 equals 2. Okay, now invert it, and now you have 1 over 2. Can you reduce that? No. So you can't reduce 2 over 1 either, because it's the reciprocal. You should not reduce it. We say that we can. That's a mistake. No, you can't, because the 2 on top is no longer a freestanding counting number. It's not a counting number. It's a proportional number to unity. And we were taught in school, brainwashed, that 2 over 1 equals 2. No, it does not. For reasons which are quite subtle from one aspect, but absolutely decisive from a strict mathematical approach. So to conclude, let's see how this might change our perspective on numbers, on what they measure. We're not using counting numbers for apples and oranges or anything on the line, but we use the same concept because we're counting Planck units, which are apples, and they're all the same apple, except it's not a rosy red juicy apple. It's a space on a line with nothing in between the 2 points. That's a Planck length. So now we have the true definition of what counting means mathematically. We're not counting apples. We're counting space units. That's called distance. Now look at the two-component number. You have 2 over 1, which I say is a proportional number. It's 2 in relation to unity. If you invert that, you have 2 in relation to unity, but in some opposite sense. It's not linear opposite. What is it then? It's multiplicative opposite instead of additive opposite. So there's a huge difference in the basis of the multiplicative system than there is in the linear system. The linear number system is a one-component system, 1, 2, 3, 4. This is not. This is a two-component number system. And now it is necessary to use human language for a geometric concept which is guaranteed to confuse you for a moment. So you're going to have to use your intelligence in order to completely understand what I say next. 1 over 2 is a two-component number. We just said that hypothetically or axiomatically, depending on how you want to phrase it. I say axiomatically because I know the full proof. But if you have not yet intuited the full proof, this is a hypothetical statement to you, which you should now accept because I'm not going to lie to you. I'm going to prove to you what I just said. 1 over 2 is a two-component number. I believe you can accept that. So let's go on and look at 2 over 1. That is also a two-component number. It's not 1 and negative 1 that are ranged around 0. It's 1 over 2 and 2 over 1 which are ranged around 1, because 1 is what they multiply to. 1/2 times 2 over 1 is 1. That's the beginning of the binary number system, which you can now see is a two-component number system, but here's where it gets bizarre. That 1 over 2 is a proportion. It is a number. We just use two numbers to make one number. That's where your mind might split and you might go insane. I certainly don't think you're going to go insane by saying that 2 over 1 is a two-component number that is a number. It's not 1, 2, 3, 4. It's 2 over 1, which is one number. It's a two-component number. Now, if you invert it, you have two-component numbers. If that confuses you, stop and listen again so you don't have to rewind. 1 over 2 is a two-component number, but it's just one number composed of two numbers. But it is one two-component number. It's like 1, 1 was one racehorse. 2, 2 was 1, 2. 1, 1, 1, 1 horse race. 2, 2, 1, 1, 2. I hope that lightens your load. I have to be precise here because this is the turning point of your understanding of mathematics. That is a two-component number system. Not because there are two numbers in this number and two numbers in this number. It's because these two numbers are two different numbers. That's the two-componency. Is that when you have a dyadic fraction, 1 over 2 is the simplest of the dyadic fractions. That means there's a 1 in either the numerator or the denominator. If the 1 is in the numerator on top, it's less than 1, right? Because of proportionality. All right, now you see. Now you're starting to see. Now look at 2 over 1. That is the inverse of 1 over 2 in multiplicative space. For this reason, when you have 2 over 1, and you invert it and have 1 over 2, those are two what we call divisional numbers, but now you know I've renamed it. They're proportional numbers. And they're reciprocal. That's the correct designator for that relationship. What does that mean? That means you don't use add because you're not on the line. You're not using linear anything. You're using something else because the line has 0 at the center. This number system has 1 at the center. That's called binary. So 1 over 2, remember all the numbers have to be whole numbers because only whole numbers are actual numbers. And they have to be positive. For reasons I stated, please listen to this again all the way through if you have to. But this is absolutely correct. We now have a new number system. Does it have any use? Yes, it does. It's the proportional number system that's not based on 0 and not based on add and not based on the line. Those are three categorical terms which now need to be replaced. On the line, you have 0 and you have add and you have one component numbers. Here you have two component numbers whose relator is not add but multiply. They multiply not to 0 but to 1. That's binary. There is no 0. Already a tremendous advantage because as I proved to you, well actually Euclid stated it. 0 does not exist. It's not a number. But 1 is a number. It's a linear number. And now here comes a spookiness that will be transitory, so don't let this faze you. When you multiply 2 over 1 times 1 over 2, what's the result? You could say that it's 1. Think. This is a two-component number system in two senses. You have two-component numbers. Since it's a two-component number system, because 1 over 4 times 4 over 1 also multiplies to 1. And that goes on infinitely in two directions at the same time. So as the greater than 1 numbers go 2, we'll just say 2, 4, 8, 16 for the time being, because that's true binary. Because it's a base 2 system. For reasons I think you can see. Of course it's a base 2 system. You have two-component numbers. Well, that's a base 2 system. If you put 1 at the center of the system, that's called the Archimedean of the space. The Archimedean of linear space is 0. That's additive space. That's why we call 0 the additive identity. It's because it's the linear Archimedean. In this system, you don't have a point at the center. You have a 1. But is it a one-component 1? No. It's a two-component 1. You can say that that's reducible to 1. No, we disallow that. Nothing is reducible in this system. It's 1 proportion 1. 2 proportion 1 times 1 proportion 2 is 1 proportion 1. Let me translate that for you to modern physics. Max Planck essentially discovered this. That 2 over 1 times 1 over 2 has a relationship called reciprocity. They're reciprocal because they multiply to the multiplicative identity. So they're reciprocal numbers on 1. Can we translate those three numbers? 2 over 1 times 1 over 2 equals 1 over 1. Can you translate that to physics? You might, but I'll tell you. But give it a moment's thought. What would 2 over 1 represent in the universe? What would 1 over 2 represent in the universe? That's very difficult to decide unless you already know, so let me give it away. Do you know what is the relationship between wavelength and frequency for light? Do you know the relationship between wavelength and frequency? Let me ask you a leading question to help you. If you can't guess, I will tell you. If you know the frequency of light, do you know its wavelength? The answer is yes. What is the lowest frequency that light might have? Do you know that? You might guess it's 2. The lowest wavelength of light that's even conceivable is a wavelength of 2. That's pure mathematics. You can't have a wavelength of 1 because it would go forever. So that's an infinity. You can't have a wavelength of 1. You know why? It's because you can't have a frequency of 1. So what's the lowest frequency? It's 2. Therefore, the lowest wavelength is 1/2. They're reciprocal. Wavelength and frequency are reciprocal. Well, Max Planck formulated a most interesting equation that relates the wavelength to the frequency in a stunning manner, which leads to quantum mechanics, believe it or not. Why is wavelength reciprocal with frequency? Why? You may or may not know, depending on your immersion in this topic, but it's actually patently obvious the reason if you know the curve. The sine wave is what it's called, which is actually the linearization of a circular function, which is now getting into such depth that I hope you're either tremendously blown away or you're not blown away at all. because this is very, very spooky now, because now we're talking about reality. Because wavelength frequency always multiplies to 1. Do you know how Max Planck formulated that? I could leave that for some very beneficial homework, but I don't believe in homework, although you should do the homework anyway after I tell you the answer. If you're measuring in Planck units, which we certainly want to, this would not be a linear Planck unit on linear spatial separation. It's a different Planck unit. There are different Planck units. For instance, on a circle, you would not have a linear Planck length. Getting into it, I hope you're starting to see some things, but if you're not, don't be dismayed. I'm going to show you the answer right now. But I have to just describe it for now the way Max Planck stated it, which is in all the textbooks. If you multiply the wavelength times the frequency, what do you get according to Max Planck? We say it's 1 proportion 1, which is mathematically true. But what does Max Planck say that 1 proportion 1 means? It's light speed. That's light speed. So we just discovered the number system that explains electrodynamics. Your physicists are not using that number system at all. Can you explain that? Please don't try. You could consult some of my prior videos, but it gets rather intricate. And it's really off topic. We don't need to know why science went wrong. Although you might want to know. You only need to know how to correct the matter. That's what I'm doing. You're using the wrong number system. Linear mathematics fails because it's using a linear quantum jump. Whereas when you have two-component numbers, you have a split jump in spherical space. We'll be right back with more. I need to get some fluids. It's going to be another hot day here in Chico. On this 3rd day of August 2025, I sincerely pray, hope, if you prefer that term, that you understood everything that I just said. Because this leads into a wonderland that is no longer psychotic. It's rational, provable science. Beginning at the unity of light speed on a natural 2-component number system based on the binary number system, that is what the universe uses. The physicists don't. And that's the situation right now. Keep looking up every night. It's the best time you'll spend on Earth. And if you're blind, that does not stop you. You merely do not have the use of your physical eyes. You have mental eyes. They're going to be more powerful for you than the physicists' eyes have been for them. And I mean that because that has been proved by physiology. If you do not have use of your physical eyes, that will not stop you at all. So stay tuned, please. We'll be right back. Thank you.